Let's learn scientific notation. So welcome to Monroe Tutoring, where I believe that understanding is fundamental, because if you learn by understanding as opposed to memorization, it'll stick with you forever, and then you can apply that understanding to new things. So let's get to it. Let's learn scientific notation, and we're going to just start off with an example to jump in with 2 feet here. So let me make something up like 6,010,000 and no decimal point, okay? So if you are asked to write this number in scientific notation and they don't request that you use a certain number of significant figures, you're just going to take the number of sig figs that are in the number, and I explain how to do that in my other video on scientific notation. So we're going to take the sig figs that this has when there's no decimal point. If you remember from my other video, we just go from the first to the last non-zero. So we're going to write those down, and we're going to put the decimal point after the first digit. So here we go. Now, in order to understand scientific notation, we have to know what it is we're actually doing, right? So the question is, how many times do you have to multiply this number by 10 to get back the original number? And so, in other words, if you know that multiplying a number by 10 moves the decimal point to the right one time, another way of phrasing this is, how many times will we have to move the decimal point from where we put it to where it was? So in this case, it's 1, 2, 3, 4, 5, 6 places. Okay? So that means we're going to multiply this by 10 6 times. Because again, every time we multiply a number by 10, we move the decimal point to the right one spot. So 5 times 10, we move this to the right one, and we get 50. If I multiplied it by 10 twice, or 10 to the second power, I'd move the decimal point to the right 2 times, and I would get 500, okay? So now, in this example, we had to move the decimal point 6 times, so it's going to be 6.01 times 10 to the 6th, and so these are the same number. They have the same value, right? Again, when we are writing in numbers in scientific notation, we're not changing the value of the number, just how we're writing it. And in this case, for 6,010,000, it may not appear so efficient or so useful to write it in scientific notation. But what if there were 20 more zeros at the end of this? Are we going to want to write out the 26 digits after the 6 here? No, we're not going to want to do that, right? So that's one utility of it, is just ease of writing very large or very small numbers. But the other thing is, what if when this measurement was taken, whatever this is, we're counting something, or this is a mass, what if this 0 was significant? So let me rewrite this number. So it was 6,010,000. And my question is, if this 0 here was significant, how can we write this number with 4 significant figures? Well, we can't write it the way it is now with 4 sig figs, because these trailing zeros are not significant. So in other words, this only has the 3 sig figs. And if I put a decimal point here, well, that makes all those zeros significant now. And so if the precision of your measurement was not that precise, like I said, the last digit that is significant is in the thousandth place, you really don't have a way to represent that in standard notation. You would have to use scientific notation. And if we wanted the 4 sig figs, we just throw that 0 in over here. And now, again, it still has the same value, but we are representing it with 4 significant figures, all right? So that was an example by using a large number. Now let's do a small number. So let me get rid of this stuff here. And the same method applies. But now, if we have small numbers, the question is, how many times will we have to divide the new number by 10 to get back the original? So let's look at it this way. We take our significant figures. So I'm going to do 5.02. And then we're still going to write times 10 to the, but now it's how many times are we dividing this number by 10 to get back the original number? So just like when you multiply by 10, it moves the decimal point to the right one spot. When you divide by 10, it moves it to the left one spot. And so, in other words, if we had moved the decimal point to here, right, that's how we're writing it now, we'd have to divide by 10 1, 2, 3, 4 times. And in order to show that we're dividing by 10 here, we do it to the negative fourth power, okay? Now, if you either don't recall or maybe you haven't done this yet in math, how negative exponents work, if we have, let's just say a to the negative n power, right? So this could be 4 to the negative third, whatever it is. This is equal to 1 over a to the n. So a negative exponent just means that this whole thing is basically in the denominator of a fraction with 1 as the numerator, right? So it just means 1 over or the reciprocal of this with the positive exponent. So multiplying by 10 to the negative fourth is the same as multiplying by 1 over 10 to the fourth, which is saying we're dividing by 10 4 times. All right, guys? So now just to go back to the simpler view here, the other way to say it is how many times do you have to move the decimal point to the left to get back to the original number, okay? So I want you to understand what we're doing. That negative exponent means we're dividing by 10 this many times, and that's why I move the decimal point to the left in this case, and the opposite for the positive exponent, right? So now that we've done this, let's go ahead and start off with something in scientific notation, and then convert it back to standard notation. And while we're doing that, guys, I just want to mention, if these videos help, please give a like, follow, share, comment. If you have any questions about this topic, feel free to ask, or if you have any requests for a different video that you'd like me to make, or if you just want to drop in and say hi, that's welcomed as well. All those things help the channel. And if you'd like to go further and help me to continue making these videos for free, you can patronize me, check out my links over there. And again, that helps me to continue making these things for free for you guys. All right, so let's go back to it now. And let's do an example like, I don't know, 2.010 times 10 to the negative sixth. So now when we're going the other way, this is saying, here's the number, and we're dividing it by dividing it by 10 6 times. In other words, we write down the number, so it's 2010, the decimal point was here, and we just move the decimal point to the left 6 times. When it's a negative exponent, we're dividing by 10, so that goes to the left, right? So then we just go 1, 2, 3, 4, 5, 6. This is where the decimal point is now going to be in standard notation, and we just fill in all those places with a 0. So we go 0, 0, 0, 0, 0, and then there's a 0 in front of the decimal point as well, right? So again, same value, just scientific notation and standard notation. And now if we go the other way, let's just make that a positive 6. And now we're going to take the number 2.010, and we're going to move the decimal point to the right this time, because now we're multiplying by 10 6 times. So we go 1, 2, 3, 4, 5, 6. Put the decimal point there, fill these in with zeros. Now, again, and let's just rewrite this now. So we have 0, 0, 0, there's a comma, 0, 1, 0, and then our 2. So we have 2,010,000. Now, in this case, we have 4 significant figures here. In standard notation, there is no way I can write this that it has 4 significant figures, right? Because if I don't put the decimal point there, I only have the 3 sig figs, and if I put it there, then all those zeros are significant. So again, that just proves the utility of using scientific notation. Guys, if this helped, please again support the channel by liking, following, sharing, commenting, even saving. And then again, if you'd like to go further, you can patronize me, check out my links. So I appreciate it, and I'll see you guys in the next one.